to standards of measurement. So today we're going to go over the measurement system for scientific measurement and then just everyday measurement as well. Okay, so whenever we are measuring anything, we need to make sure we include a number and a unit. So the unit is important in order to communicate exactly what you mean. Okay, so if I say, meet me here in 5, you are unsure if you mean 5 seconds, 5 minutes, 5 hours, 5 days, 5 years. Okay, so it's important to include a unit in order to understand what your measurement is actually telling us. Okay, so we are most familiar with the English system because it's the one that we learn throughout our school years. So this includes things like pounds and ounces, gallons, cups, feet and miles, yards. Okay, but the one that's most commonly used throughout the world and what's used for scientific measurement is the International System or the SI system. Okay, so this is the standard for scientific measurement, and it'll be what I expect you to use in science class. Okay, so the system, it has a larger scale than this, but this is just the scale that I'm going to ask you to learn. Okay, so we have the base, and so it's important to know the base units of the SI system. Okay, so the L stands for liters, G stands for grams, and M stands for meters. Okay, so if we walk up the scale, okay, these numbers are going to be bigger, whereas these ones are smaller. So if we walk up, we have deca, so like decaliter, decagram, decameter. Okay, this is going to be 10 times the base unit. Okay, so if we have 1 decaliter, that would be equal to 10 liters. Okay, then we have hecto, so like hectoliter, hectogram, hectometer, and then kilo. Okay, so like kilogram, so if we have 1 kilogram, that would be equal to 1,000 grams. Okay, and then if we move down the scale, these numbers are going to be smaller than our base unit. Okay, so we have deci, so like decigram, centi, like centimeter, and milli. Okay, so these, if we're looking at like milliliter, it is going to be, so like 1 milliliter is 0.001 liter. Okay, or inversely, if we say 1 liter equals, and it would be 1,000 because it's 3 decimal places, so 1,000. So 10, 100, and 1,000, but it would be inverse. So 1 would equal 10 deciliters, 1 would equal 100 centiliters, and then 1 would equal 1,000 milliliters. Okay, so what's nice, because it is this 10-base system, it is easy to convert between SI units. Okay, so we can move the decimal point very easily to convert within the system, the SI system. So we're actually going to practice this with these practice problems. Okay, so the first problem is 3,075 millimeters to centimeters. Okay, so I'm going to use these dots in order to do our start. So our start is millimeters, so M. Okay, and then we're going to centiliters, which is right here. Okay, so if we look, we're going to jump 1 box to the left. Okay, so how we easily convert this is we're going to move the decimal point 1 spot to the left. Okay, you'll notice this number doesn't have a decimal point shown. Okay, so if you have a number like this, it is known that the decimal point, even though not shown, is at the end of the number. Okay, so remember we're moving 1 to the left, so we're going to move 1 space to the left, so our new decimal point will be right here. So our answer will be 307.5. Okay, moving on to the next problem, we're going to start with kilometers. So I'm going to move my green dot to kilometers. And then we're ending in meters. Okay, if it only has 1 letter, that's your base unit. Okay, a lot of times people get confused and they will put this on millimeter and they'll go too far. Okay, we're just going to the base because there's only 1 unit. This is only meters, not millimeters. So I'm going to move my stop point to meters. Okay, so we're going to jump 1, 2, 3 to the right. Okay, so we got to find our decimal. On this problem, there is no decimal, so it's at the end of the number, so here. We're going to be moving to the right. Now you'll notice there's no numbers to the right. Okay, so we're going to keep track of how many times we jump without a number, and that's how many zeros we're going to add to this number. Okay, so 1, 2, 3. We jumped 3 times without any numbers. So we had 89, and we're going to add 3 zeros for our jumped loop. So 1, 2, 3. Now you can go back and put the comma here if you want to separate your thousands, but it's not a big deal if you don't. Okay, you'll notice too that I am including the units for you in all of these, so you don't have to rewrite the unit. Okay, but if there was no unit, you would need to make sure and add that or include that. Okay, for the next practice problem, we're starting with liters. Okay, remember again, it's showing us one letter, so that's going to be our base unit. So put my green dot on base, and we're going to decaliters. So here is my stopping point, DK. Okay, so we're jumping 1 to the left. So find the decimal point. There is none, so it's at the end of the number. We're jumping 1 to the left. So one spot, it's going to be 1.4. Okay, for the next one, we're starting with hectoliters. So move my starting point. 2 centiliters. Okay, so we're going to jump 1, 2, 3, 4 to the right. Okay, so find your decimal point. We actually have the decimal point in this problem. So start on the decimal. We're going to move 4 to the right. So 1, 2, 3, and you'll notice we don't have another number, so we're going to keep track. We jumped 1 additional time for it to be 4, right? 1, 2, 3, 4, so we're going to add a 0 to the end of this number, okay? And so it would look like this, but we know that we don't write numbers that way, so it's just going to be 450. Okay, for the next one, start at DG. So D is our decigram, and we're going to hectogram. So ending on hecto, we're going to jump 1, 2, 3 to the left. Okay, start at your decimal point. We don't have one, so it's at the end of the number. So we're jumping 1, 2, and then we're going to jump one more time to get 3. So remember, we're going to have to put a 0 there, so this will be our new decimal point. So we're going to have 0.044 because we jumped 3 times. 1, 2, 3. So there's going to be a 0 that we have to add in. Okay. The next one and last one, we start with G, grams. Okay, it's one letter, so we know this is our base. And we're going to milligrams. So move my stopping point to milligrams. We're going to jump 1, 2, 3 to the right. Okay, so start at your decimal point, which we don't have one, so it's at the end of the number. We're going to jump 1, 2, 3. So we jump 3 times to the right, so we're going to have to add in 3 zeros. And again, you can add a comma if you want, but it's not necessary. Okay, continuing on with our notes. Let me just jump through. Okay, we have length. So this is the distance between 2 points. Okay, so this is going to be your meter. Okay, so meter, kilometer, millimeter, centimeter, these are all units of length. Okay, and in the lab we will use a meter stick in order to measure the distance of length. Okay, not a yardstick that has inches on it. We want the meter stick that has centimeters, and then it is a meter in itself. Okay, a volume of an object is how much space something takes up. Okay, so for a solid object such as like a box, so let's say a Kleenex box, we can measure the length, the width, and the height with a meter stick, multiply those together to get the volume of the object. Okay, so because we're multiplying three different distance or length units, we're actually going to have a unit of centimeters cubed. Okay, so if it's, let's say, 2 centimeters by 2 centimeters by 2 centimeters, we'll have 2 times 2, which is 4, times 2, which is 8. So 8 centimeters cubed, because we're multiplying those three lengths together. Okay. Also, we can use liters for volume as well. And generally, we use liters whenever we are doing volumes of liquid, but we can also use liters whenever we are measuring a object that we can't necessarily just measure. Okay, so let's say we have a toy car. You can't really take the length, width, and height accurately in order to find the volume. Okay, so in order to find the volume of this weird object, we use the displacement method, okay, which is using a graduated cylinder. So say you have a graduated cylinder that has 10 milliliters of water in it, okay, you drop the toy car into the graduated cylinder, and then the water level will actually rise. This is the displacement of the object, okay? So let's say the new water level with the car inside of it is 17 milliliters, okay? So it was at 10, now it's at 17. There's a difference of 7 milliliters. That is the volume of the toy car, okay? So that's the displacement method, right? Matter. All matter has mass, okay? And so the mass of an object is just the amount of matter in that object. So you can think of it as the particles that make up that object, okay? This is measured with grams, kilograms, centigrams, milligrams, okay? And the tool used for that is a triple beam balance. Now, weight is something different. So weight is the response of mass to the pull of gravity, okay? So your mass is just the amount of particles that are inside of you, or the amount of matter that you're made up of, okay? But gravity is going to affect your weight. So that's why whenever we see videos of like astronauts up on the moon, they appear to be lighter because the pull of gravity of the moon is less than here on Earth. Okay, and then lastly, density is mass per unit volume. So we could take mass divided by volume in order to find density. And there will be an activity that will help us better understand density.